Okay, let's look at the practice exam 2, problem number 7. Right. So we are looking for discontinuity of this piecewise defined function. Right. So first thing we should pay attention is that each piece, the top one 2x, this is a linear function, and the bottom one is also a linear function. So these guys by themselves are continuous everywhere, right? The only problem can occur is at the gap between these two pieces, which is x equals 1, right? So let's take a look, right? So question boils down to is this function f continuous at x equals 1, right? Right, that's the only place this discontinuity can occur, right? So let's check. Remember that in order to be continuous at 1, we have to have this equality. So the condition is you take the limit of this function as x approaches 1. This has to agree with f of 1, right? Then you have to notice that, remember that in order to have this equality, we have three things that we need to check, right? So first one, we have to make sure that the limit exists. So limit f of x as the x approaches 1 exists. Two, right? So then we have to make sure that the f of 1 is defined. Right? Number 3, right? Number 1 has to be the same value as number 2. Right? So those are the three things we have to check. If one of them fails, then it's not continuous. So therefore there's a discontinuity there. Right? Let's check the first one. Right? In order to find the limit, we actually have to look at the one-sided limits first. So limit f of x as x approaches 1 from the left, right? Since it's approaching from the left, so it's going to be less than 1, so we have to use the top formula. So it's going to be a limit as x approaches 1 from the left of 2x. All right? Then you have a plug-in, so you have 2 times 1, which is 2. Right? So that's left-hand limit. Let's look at the right-hand limit at x equals 1. Right? So f of x as x approaches 1 from the right. All right, so since x is approaching from the right, we have to use this guy when x is bigger than 1. So the formula is the bottom formula. So limit as x approaches 1 from the right. The formula we use is 5 minus x, right, which is equal to, right, 5 minus, we plug in 1. Right, which gives you 4. Right, so you can see that the left-hand limit and the right-hand limit gives you a different value. So this implies that limit of f of x as x approaches 1 does not exist. Right, so therefore we already failed the first condition, which means that f is discontinuous. So we say, therefore, f is discontinuous at x equals 1. Right? That's it. I hope that this was clear.